Have you ever had a slight feeling of anxiety when touching something outside of your home? As I speak, there is a crisis unfolding, the crisis of antibiotic resistance. Bacteria are naturally becoming resistant to one antibiotic at a time, but for us, it is getting increasingly harder to deliver new antibiotics to the market. Tens of thousands of people are already dying each year due to infections for which we used to have treatment, but not anymore. The most dangerous and resistant strains of human pathogens reside in hospitals, where huge amounts of antibiotics are being distributed, forcing bacteria to develop resistance. A very concerning fact, considering that in Canada, around 8% of all hospitalized patients face healthcare-associated infections. Infections that patients get within the hospital, besides the initial reason of hospitalization. And those infections are predominantly antibiotic-resistant. Perhaps main hotspots of disease transfer in hospitals are frequently touched surfaces. Handrails, doorknobs, and light switches allow rapid transmission of pathogens from one person to another, and apparently conventional surface decontamination practices are not preventing the spread. If only we could produce a doorknob that sterilizes itself, right? Or can we? My project is focused on development of antimicrobial coatings for frequently touched surfaces in clinical environments. These coatings are designed to kill bacteria upon contact and to repel them from the surface. Superhydrophobicity, a repelling property, is mainly achieved by building a nanotextured layer on aluminum surface. That nanotexture, with some modifications, inherently pushes the water away. Contact killing property, on the other hand, is achieved by anchoring a specific type of antiseptic to the surface, quaternary ammonium compound. Unlike conventional antibiotics that tend to attack a precise target within bacterial cell, allowing bacterium either to defend the target or to completely get rid of it, quaternary ammonium compounds attack bacterial membranes in a non-selective way, severely reducing the space for bacterial evolutionary maneuvers. With further optimization of our methods and alignment of our solution with safety regulations, and with eventual prototype development, we expect not only to save tens of thousands of lives, but to make sure that those lives are not facing the danger at all. Because from touching the doorknob, there should be only one outcome: you coming in. Thank you.